So with that, I'm going to move over to this part here, because the question was, how do you handle pattern of holes defined as a datum? So with this part, again, if I go into, I change the mesh color so there's an offset, so it always kind of confuses me with the tree, because the parts up here is green in the DCS tree, and you can see there's no GD&T. So real quickly, I'm going to add some GD&T on here. I did say datum, right? Okay, I wasn't sure, so I had to back up. Datum A, oh. Datum A, add. Pick that surface, okay. Okay. Size, add. We'll leave it 0.2. Just to check real quick, if I zoom in here and say deviate, okay, I can see the size is moving. I created points on here because sometimes that helps you see stuff. So I'll come in here and I'm going to add a position tolerance, add. And you'll see, here I'm adding a position tolerance on a round feature, so I want to set it to diametrical. I'm going to set this to 2 millimeters. I have no datum reference frame. Okay, I really only want to, because I'm going to make that my datum, so I have to go to my datum reference frame, and I need to make a datum reference frame A. Apply. Now I can come back here, and now I have datum A, reference frame 2 millimeters, say okay, okay, okay. And then I can continue on. Actually, I should be able to. Datum, add. Datum B. Okay, so the issue was, how is the parts constrained when you have a hole pattern as a datum? So we know if I, make these two holes datum B, then that's going to control my left and right and my, it's going to control my Y variation and my X variation when it's assembled. The constraint system is taken care of by the moves. So all I did was tolerance this part. It should deviate. Okay, and so you can see it's got the hole position tolerances, then that pattern of holes is datum B, and the bottom surface is datum A. How that is taken care of is in the moves. If you look down here, I added 2 moves. My original move is a feature move, and it's using this hole as its 4-way locator and this hole as its 2-way locator. And if I go into the measurements, I'm measuring whether or not this hole is crashing through that pin. So if I only have the feature move, which is primary, secondary, and tertiary, or if I'm using our step plane or 6-plane move, I don't get to use both holes as a locator. So when I do a nominal build and I run an analysis, you can see that measurement, checking this pin, is crashing a lot, okay? But that's because the move is not using both pins to locate this part as a whole pattern constraining that part. For that to happen, we have to add the pattern move. And the pattern move is picking both pins in both holes. If I activate the pattern move and run another analysis, now you can see that that circle interference measure, which was right here, is good. It's either net or it's got a clearance. If you tolerance your parts badly and it can't solve, so I'm going to come into the rocker. Come on. Rocker. Oh no, it's the lifter. I'm sorry. Where's my lifter?
It's the lift to the green one at the top.
Thank you. Yeah, so I'm going to go into this position tolerance and I'm going to change it. Notice now how we've combined this. This is a little sidebar. I wrote two separate callouts. I put a size tolerance on these holes, and then I put a position tolerance on those holes. But now if I go into either one of these, it's showing me that, hey, these two features have got a size tolerance on it of 0.2 and a position tolerance on it of 2. And you can edit, either one of these. I forget how to make that arrow go up there. On the very top. Oh, up here. Okay, thank you. So you can see it's showing us everything that's applied to these features. And depending on what I want to edit, I can hit this pull down and change where this arrow is pointing to. I want to just change this to 3 millimeters. Okay. Get a visual so you can see those are moving around a little bit more now. And then when I build this and run an analysis, now you can see it's still built, but now it could only build 1,982. So based on how we toleranced our parts and how we're trying to constrain it, meaning locating the lifter with the whole pattern, it can't solve it. So now you would have to address this by either increasing the clearance holes on increasing the holes on your lifter, decreasing the position tolerance on your lifter, decreasing the pin size on your base, whatever you need to do.